we are going to discuss chemical equilibrium, and one of the question which came in under this topic in 2019, that is the question number 13. So this also consists of 2 marks in that question paper, and this is a numerical aptitude answer test or a NAT question like the previous question that we have discussed just now. So the question is stating as the pH of a 1 liter buffer solution containing 0.2 mole of acetic acid and 0.3 mole of sodium acetate is 5. The Ka of acetic acid is P into 10 to the power minus 5, where the numerical value of P rounded off to 1 decimal place is. So they want the value to be rounded up to 1 decimal place, and here you are facing a problem where there is a buffer solution and there is a weak acid and its conjugate base, and all these values are given. So this kind of where the pH is also given of the buffer, and if you have some idea about chemical equilibrium, then this kind of questions is somehow related to Henderson-Hasselbalch equation, because there we are actually calculating the pH with respect to the weak acid conjugate base pairs. Okay, so for specifically for this kind of buffer. So now let us look to the Henderson-Hasselbalch equation. So what is the Henderson-Hasselbalch equation in chemical equilibrium? This is very important not only for solving your chemistry questions but also for some titration questions in the amino acid part in biochemistry. So that's why I included this question. So Henderson and Hasselbalch equation is stated as this equation shows a relationship between the pH or pOH of the solution with the pKa or pKb and the concentration of the chemical species involved. So it is a relation between the pH with your pKa or pKb. Here it is the acid dissociation constant and Ka and Kb is the base dissociation constant. And this is only applicable if it is either a weak acid or is a weak base. So these are the two equations. If it is a weak acid we are considering, then this is the equation, and if we want to find the pOH, then this is the equation. Okay, just remember that if you don't change this, means numerator or denominator, then the sign will change. Okay, either of them is okay. Just remember like this. Now if what is this equation, how, from where this is coming? So if we take a example of a weak acid, this is Ha. When you dissolve it in a solvent, it will dissociate into H plus and A minus. So here A minus is your what is this? The A minus here is your conjugate base. Now if you want to calculate the Ka, that is the acid dissociation constant, that is Ka. So this value is coming as if you remember how we calculate the K equilibrium, just I discussed before. So in the same way manner, the concentration of the product, that is the H plus multiplied by A minus divided by Ha. Now we are taking negative logarithm in both the sides. So it is coming as minus log Ka of this. Okay. Now if we again further solve this equation, we get this equation. Now we know by definition that is minus log of Ka, like minus log of hydrogen ion concentration is pH. So minus log of K is pKa. So just using that knowledge and substituting those values in this equation, we get this equation, that is pKa equals to pH minus log of A to the power divided by this Ha. Now the equation is then rearranged to form the Henderson-Hasselbalch equation. So there is, it was pKa, so pKa we are taking this side, pH we are taking this side. Okay, so the pH, when we change the sign will be positive here, that is pH equals to pKa plus log of A divided by Ha. So this will be your equation. Okay, now by knowing this knowledge, now let us look in this question again. So the question tells that the volume of buffer is given, that is 1 liter of buffer, and your concentration here of the acetic acid, it is given in moles, but it is in 1 liter buffer, so you can consider it as molar. Okay, so 0.2 molar and 0.3 molar of sodium acetate, and the pH of your buffer is given as 5.0. Now what you need to calculate is this Ka value where you require this P. Okay, so how to do that? So first write the Henderson-Hasselbalch equation. So pH, and also mind it that this is a weak acid base pair. Okay, this is an acetic acid and its conjugate base pair. So that's why we are actually able to use this Henderson-Hasselbalch equation here. Okay, so now pH is given by pKa plus log of conjugate base. As you see here, I have written the equation of Henderson-Hasselbalch equation. Now pKa, what we know, is minus log of Ka, just we saw in the derivation. So here Ka value is already given in the question, that is P into 10 to the power minus 5, where we actually require to calculate this P value. Now we have marked this equation as 2, and in the first it is 1. Okay, now substituting this 2 in 1 means we are substituting the value of pK in this Henderson-Hasselbalch equation. So by this the pH value is already given as 5, so it is 5 equal to minus log of this pK, since it is the value, minus log P into 10 to the minus 5 plus log of conjugate base by acid. So here if you see that the sodium acetate concentration, which is your conjugate base, is 0.3 mole, and of acetic acid, that is your acid, is 0.2. So that's why I have written here log 0.3 by 0.2. Now just you need to do some mathematical calculation. You have to calculate this log value, then transpose it in this left hand side and calculate this log value, and you will get P into 10 to the power minus 5 equals to anti-log of this. You take the anti-log of minus 4.82, and this 10 to the power minus 5, 10 to the power minus 5 will cancel out, and you are getting P equals to 1.51. Okay, but here you actually, they have said that round off to 1 decimal place, so the answer will be 1.5 here. Okay, so the answer will be here 1.5. So this is your answer. So this is all what I need to discuss in this video, and for reference to know more about this rate kinetics as well as equilibrium, I have given two links or two courses. One is rate processes by Dr. M. Haldar of IIT Kharagpur, and also Dr. Amber Jain, whose course runs on chemical kinetics and transition state theory in NPTEL. So you can refer to these two NPTEL courses for getting more insights about chemical equilibrium and chemical kinetics. Thank you.